Okay, here we go. What you're looking at here, all right, guys, let's focus. What you're looking at here is a polar grid. It is still the same as always. This is still the x-axis. This is still the y-axis, like always. But it's now, you see all these circles, right? So what you're looking at is a polar grid. This small circle that you see on the inside has a radius of 1. So we're going to call that r equals 1. Then the next one is r equals 2. So instead of a unit circle, which means, that the r is 1, now we just have a whole bunch of circles. R equals 2, and so on and so forth. And then the radians are still the same, power over 6, power 4, power 3, power 2. Sometimes you have a polar grid, and sometimes they give this one here in the middle, where this is pi over 12. And then power over 12 plus power over 12 is 2 power over 12, which is power over 6. And then power over 6 plus power over 12 is going to give you this one. This gap is power over 12 apart. See, 2 power over 12 plus power over 12 is 3 power over 12, which is the same thing as power over 4. And then 3 power over 12 plus power over 12 is 4 power over 12, which is the same thing as power over 3. This gap between those two is power over 12, the gap. And then sometimes they put this one here, and that one is 1, 2, 3, 4, 5. 5 power over 12. And then power over 2. Sometimes they do that. Yeah. No, okay. What's up? It's halfway. Yeah. 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 It's halfway between 0 and power over 6. So what's half of power over 6? Power over 12. And then this power over 6 plus power over 12 is power over 4. Right? Look, 2 pi over 6. Look, 2 power over 6, that's pi over 6 plus pi over 12. So look, I'm going to multiply by 2, so 2 pi over 12. So there it is, 2 pi over 12 plus pi over 12, that's 3 pi over 12. And check it out, 3 goes into 12 4 times. That's pi over 4. See? And if I take 3 pi over 12 and I add another pi over 12, that's 4 pi over 12. Oh look, 4 goes into 12 3 times. That's pi over 3. And then if I take 4 pi over 12 and add pi over 12, that's 5 pi over 12, which is halfway between pi over 2 and pi over 3. Don't relax. We haven't done anything yet, guys. All I'm saying is sometimes they show these angles as well on the polar grid. If you're wondering, man, when am I ever going to use this in real life? Well, one, we're using it right now. And two, if you're a NASA engineer or you're working with stuff in polar coordinates, if you're working with something that takes the shape of an eccentric circle or an ellipse, it's a lot easier to evaluate in polar form. Cool or not cool? Nothing crazy, right? Okay, I think we're good. So how do we represent the coordinate in polar form? Okay, in polar form, so here it is in rectangular form. In rectangular form, you say x comma y. Rectangular is the same thing as Cartesian. That's what you've been doing all your life. Two-dimensional. In polar form, you go r comma theta, where r stands for radius, which is like distance, really. Like distance. In physics, when you did that formula for big G times m1 times m2 divided by r squared to find the force, the r was the distance, right? Have you guys covered that yet or no? Yeah, big G m1 m2 over r squared. Okay, yeah, that's how you find your force between any two like electrons or any two objects. For electrons, they don't call it big G. Well, anyways, it doesn't matter. Or two particles, right? Really small, minute particles. Okay, it's the same thing. The theta is your angle, usually in radians. It can be in degrees, but it's usually in radians. Anything crazy? Yeah, nothing crazy. Okay, so there it is. How do we measure R? You start from the origin. Measure, comma, start from origin. Chavez, I don't know what you mean by this. I am totally confused. Here's what I mean. So let's take a point. I'm going to put a point right smack. Where do you guys want the point? Bam. Do you see that point in burnt orange? Okay, here's how we measure that. We say this angle here. What angle is that? Pi over 3. So I'm going to go pi over 3. Notice where I put it. And I say the R distance. So let's see what the R is. 1, 2, 3, 4. What's that radius of that big circle there? 5. Chav, what circle are you talking about? I'm so confused. That circle right here. We're not plotting the circle. I'm just saying I'm plotting this point, just that point. So this distance here is 5, and it's measured from the origin. 1, 2, 3, 4, 5. Yep, 5, and that's pi over 3. So this is my r, and that's pi over 3. Does that make sense how we plotted that? 5 comma pi over 3. Nothing crazy, right? Does anyone have any questions on 5 comma pi over 3? Be honest with me, guys. We're good? Okay. All right, Milo, focus. Okay, so we're good. How do we measure? Measure, you start from the origin. Always start from the origin. Cool or not cool? Okay, and then it says here, this is supposed to be you guys because I haven't told you guys yet. Chav, I remember you saying earlier that R can never be negative, but now it can. Can you help me here? R can be negative. Chav, how? You always, okay, relax, it's in context. R is like a distance, and you're right, when we're working on problems and hypotenuse problems and all that, the hypotenuse is never negative. Distance is never negative because R is like distance. But in this case, for polar, it can be. So let me, hold on, before everyone's like, okay, what's going on? So look, let me erase all this stuff so we can have a clearer picture. So let me erase. That way there's less stuff, because research says the less stuff there is, the better you learn. Yeah, I read educational books too, guys. I want to be the best. All right, here we go. So here we go. There's less clutter. That is 5 comma pi over 3. I don't think anyone has any issues with that. Are we okay with that? Okay, so check it out. So don't write this down, just listen. I could have said this. If I go all the way to this one, notice this is 4 pi over 3. So I'm going to write 4 pi over 3. Now, if I told you that r is, don't write this down, just listen. If I told you that r is negative 5, remember, you always start from the origin. So here's the angle that I'm looking at. This is my ray, 4 pi over 3. Are we okay? If I tell you that r is negative, you're going to go, quote unquote, backwards. So because my ray is pointed at 4 pi over 3, because that's what my angle is. Positive is just like this. Like this is r equals 1, r equals 2, r equals 3, r equals 4, r equals 5. But if I count negative, it's like going backwards. 1, 2, 3, 4, 5. This point now is now negative 5 comma 4 pi over 3. Do you see what I did? Don't worry. Don't write it down, just listen. So it's like I did this. I did the angle first. So I went, this ray is at 4 pi over 3. Does everyone agree? So I'm going at 4 pi over 3, and then I tell you, okay, negative 5. You're not going to count like this. You're going to count negative 1, negative 2, negative 3, negative 4, negative 5. You're walking backwards. So this point here, I could label it 5 comma pi over 3. This is correct. This one here is also correct. Negative 5 comma 4 pi over 3 would be that point. See, the ray, and then count backwards. 1, 2, 3, 4, 5. You go the opposite direction. Does that make sense? And of course, there's several answers. You could actually add 2 pi to this and be there again, a different angle, but same magnitude, 5. So 5 and pi over 3 plus 2 pi, whatever that is. Let's see. 6 pi over 3 is 2 pi, 6, 7. 7 pi over 3, comma 5. 5, comma 7 pi over 3. Does that make sense, guys? So all three of those are the same as this. So you look, r is negative. It really is a negative. But in polar coordinate, negative 5 comma 4 pi over 3 is that point. Cool or not cool? Cool. Okay, guys, we're good. Write down what you got to write down. I'll put it here. I'll put a little grid here. And I'm going to reference that point up there. Negative 5 comma 4 pi over 3. And see video. When I say see video, see this video. That one. That I'm about to upload on YouTube whenever we're done. How do we feel? Nothing crazy, right? Okay. Chab, I remember, we just, this goes down here. Okay. How do we feel? Nothing crazy? All right, go to the next page. Relax. So what's the difference between rectangular coordinates and polar coordinates? Polar rectangular conversion formulas, there's 4 major ones. Guys, I'm not trying to talk smack, I promise. I just feel, okay, And I'm not talking about any teacher, and I'm not talking about anyone in particular. So don't get twisted and go to someone. Oh, he said this, or if you, I could very easily just give you formulas for conversions, and some kids like that. Like, just give me the formula, and I'm just going to use it. But make sure you know where those formulas come from. They don't just magically appear. Do we understand that? I want to make sure that you know where all these formulas come from, so I like to derive stuff from scratch. I think that's the best way to learn. I think that's the best way to learn any math or science subject. Math, chemistry, physics, is to derive where the formulas come from and then use the formulas. If you want to be robotic, that is fine. You can be a robot if you want, but I want to make sure that you know where these formulas are coming from. Cool or not cool? So let's derive them. So here, don't worry, it's not a rocket science derivation, so it's pretty easy to follow along. So I'm just going to exaggerate the first quadrant. So exaggerate the first quadrant. I'm going to put a point in rectangular or Cartesian. That point is obviously x, y. In polar form, it's r comma theta. So which one's in rectangular? This one's rectangular, and this one's polar. And we're going to measure it from the origin. That's how you measure the r, right? So this distance here is r, and this distance here is theta. We haven't done anything crazy. We're still okay, right? Now check it out. Do you guys see this right triangle? Yeah, and so we're going to do the same stuff that we did last year with the unit circle. I'm going to put SOHCAHTOA here on the top. SOHCAHTOA. And I'm going to say, okay, well, according to this SOHCAHTOA here stuff, this acronym, I'm going to write sine of that theta is equal to opposite over hypotenuse. I guess I should label what this is. My horizontal displacement here is an x value. See, because it says xy. My vertical displacement here is a y value. So how does x, y, theta, and r, how are they all related? Well, sine theta is equal to opposite over hypotenuse. So I'm going to say y over r. When it was the unit circle, r was 1. But now we're not talking about the unit circle. We're talking about just circles in general, or I guess whatever. So from that, times r, I can say that y equals r sine theta. So this is how you're going to get your y value if they give you a polar coordinate. Or how to go the other way around if you have a y value and you need to get... Okay. Are we okay so far? All right, the x value. Well, let's do the cosine. Cosine of that angle is equal to x divided by r. I'm just doing adjacent over hypotenuse. Adjacent to that theta is x, hypotenuse is r. So that means that x equals r cosine theta. Is everyone okay with that? Nothing crazy, right? Okay. The last one, there's a theorem that relates x, y, and r together. What's the name of that theorem? Starts with the letter P. Pythagorean theorem. X squared plus y squared equals r squared. I guess there's one more. And one more. Last one. If I want to get the theta, and you could do arc sine, you could do arc cosine if you want, but usually they give you x and y. That's the rectangular coordinate. You want to usually go from rectangular to polar. If you want to get the theta, do the inverse tan. So I guess I'll write it here. Tan. Tan theta equals y over x. So how do I get theta by itself? Theta equals arc tan of y over x. Now, I guess I got to give a disclaimer. I would find the reference angle and then go from... You'll see what I mean. Let's just do it by practice. Okay. Do we feel okay so far? All right. All right, let's see if we can do some problems together. So look what it says here. Find a rectangular coordinate for the points with the given polar coordinates. We're going to go slow, guys. The first thing I would do, try not to look at the... I know that you guys are used to doing the x first and then y. Here's a hack. Do the y first, or do your angle first, because it's not the y anymore, that's the radian. Do the radian first, and then do the r. So what's my angle or my radian? Well, what's my angle? Pi over 2? So here's pi over 2. That is theta equals pi over 2. Do you guys see that? And now I'm going to do my r. The r is 4, so you start at the origin. 1, 2, 3, 4. There it is. That's my point. And they want, what do they want? Find the rectangular coordinates. Okay, this is easy. My rectangular coordinate. What's the x value there? 0. Yeah, you're right. What's the y value? 4. You don't have to do any math. Now, if you are adamant about doing some math, if you're adamant, Chop, you give me formulas, I want to do math, I don't care what you say, I just want to use the formulas. Okay, you can use the formulas like this. X equals r cosine theta, where r is 4, so you write 4 cosine of pi over 2. You get your value from the unit circle. 4 cosine of pi over 2 is 0. 4 times 0 is 0. And then if you want the y value, 4 sine of pi over 2. Chop, where is all this stuff coming from? From right here. From the x and y. From this guy right there. See? Y equals r sine theta. X equals r cosine theta. Do you need it for this one? No, because you could just get it from just common sense. R sine pi over 2. 4 times sine of pi over 2. That's a 1. Sine of pi over 2. And 4 times 1 is 4. So, what's your coordinate? Well, your x value is 0 and your y value is 4. But I would like for you to have common sense and do it visually with that grid there. Do you see how we did it? How do we feel? Okay, another one that is common sense, if you just focus. So everyone focus on this one real quick. So don't look at that -3 until afterwards. Look at this first. See how that says pi? So you do this. In your head, you're like, okay, this amount of revolution or rotation is pi. There it is. That's pi. So I'm looking at the negative. This is my ray. I'm looking at that negative x-axis. But now, look what you do. What is that r? Is that a negative r? So you're going to count backwards. Where are you at? 3, 0. Do you see how I got that point? You go. So again, let me show you what I did. I did this first. Look at that pi first. You go to pi. And then, -3, you're going to count backwards from the origin. 1, 2, 3. You count backwards. You go backwards. Do you see how we did it? Pretty simple, right, guys? Perfect. If you want to use formulas, you can, but you don't need to when it's this simple. Look, I know. Some of you want to see it. Okay, here we go. X equals, it says r cosine theta. -3 cosine of pi. Well, cosine of pi is -1. -3 times -1. Negative times a negative is a positive. Look, there it is. X equals 3. Y equals r sine theta. -3 sine pi. -3 sine of pi is 0. Oh, look at that. 3, 0. 3, 0 in Cartesian or rectangular coordinate. How are we feeling? We feel okay? Perfect. All right, guys. Let's go. Let's do harder ones. Go to the next page. Don't worry. They're not even that extreme, guys. I'm going to go by, look, I know it says my R is 16. I'm going to make this scale by 4. I'm going to say this is a 4, this is an 8, this is a 12, this is a 16. So first I look at the angle, 5 pi over 6. So where's 5 pi over 6? Here it is. And now I look at my R, 16. So let's see, 4, 8, 12, 16. So I am right here. Yep. So there it is. That point is 16, 5 pi over 6. Because this angle, I guess I'll write the R. This distance here is 16. And this angle here is 5 pi over 6. Do you see how we're doing it, guys? Ask, dime. Maybe I messed up.
Sorry, what did you do? Oh, it's by 4s?
Yeah, the scale's by 4. 4, 8, 12, 16. Because I wasn't able to fit. If I would have, I typed this out just yesterday, actually. If I would have put some thought into it, I would have made it like 5 or something. But, oh well, my bad, guys. Cool or not cool? All right, next. We haven't even answered the question. They want the rectangular coordinate. Okay, obviously, hopefully you know, the x value is negative and the y value is positive. But don't worry, you don't even have to think. You can just go like this. You can just go, x equals, what's my formula for x? Yeah, r, say it with me, say it. R cosine theta. Use it. 16 cosine of what? 5 pi over 6. The unit circle doesn't go away. So make sure you know it. 16 parentheses. What is cosine of 5 pi over 6? Square root of 3 over 2. Negative. Negative square root of 3 over 2. Then relax. You don't need a calculator for this. How many times does 2 go into 16? 8. So This answer is negative 8 square root of 3. Do you see how we did it? I know. Let me show you, because there's some of you have never understood this. So let me tell you what's really going on. This is like 16 over 1, and don't worry, it's a quick side note. So whenever you multiply this, guys, it's like saying this: 6 negative in the front, square root of 3 over 2. And then look, this is just, you have a product divided by a quotient. How many times does 2 go into 16? 8. So negative 8 square root of 3. So start making sure that you know that you're kind of good with number fluency. You don't have to be the best, but make sure that you know what's up. All right, same thing with this one, guys. The y value, 16 sine of 5 pi over 6. Well, sine of 5 pi over 16 times, what's sine of 5 pi over 6? Do you guys remember? 1/2. What's half of 16? 8. So in rectangular coordinate, negative 8 square root of 3 is my x value. 8 is my y value. That's an x and a y. See? Easy, right? Not that bad? See? Not that bad, guys. All right. Next one. Negative 2 comma negative pi over 4. Relax. Do the radian first. Negative pi over 4 is in what quadrant? The fourth. Good job. This is negative pi over 4 right there, guys. That's negative pi over 4. It's the same thing as 7 pi over 4. That's negative pi over 4 right there. Now you're going to go negative square root of 2. That's between r equals 1 and r equals 2. It doesn't have to be perfect, though. But negative square root of 2. So I have to go backwards. So what quadrant am I going to be in? The second. I'm going to be like right there somewhere. So that's negative square root of 2, comma, negative pi over 4. You could also write square root of 2, comma, 3 pi over 4. They're both the same. Are we okay? Okay. Ask. What's up? Yeah. Okay, sorry, miss. All right, let's get the x and y coordinate. X equals my r, if you want to use the negative, negative square root of 2, cosine, I guess you can write negative pi over 4. Hopefully you won't get confused. So here we go. Negative square root of 2, cosine of negative pi over 4 is just, oh man. Yeah, it's the same thing as, well, no, I use the negative square root of 2. If I were to use the cosine of 7 pi over, oh yeah, it is. It's the same thing as cosine of 7 pi over 4. Sorry for the brain fart there. Yeah, cosine of negative pi over 4 is the same thing as cosine of 7 pi over 4, which is square root of 2 over 2. Did I confuse anyone? Okay, these twos, let's see. Negative square root of 2 times square root of 2, that's a negative 2 divided by 2. So negative divided by positive is a negative, so negative 1. Do we see how we got that, guys? All right, same thing for the y value. Negative square root of 2 sine of negative pi over 4. You can also use the odd even function properties. Sine of negative pi over 4 has to be a negative square root of 2 over 2. So negative square root of 2 times negative square root of 2 over 2. Negative times a negative is a positive. So you get 2 over 2, which is just 1. So what is my rectangular coordinate? Negative 1, comma, 1. And sure enough, yep. So that means this value here, bless you, negative 1, comma 1. Yeah, because negative times a negative, right? Negative times a negative. Any questions, guys? Let me know. You guys, yeah, first period had a lot of questions. You guys don't have any questions. Okay. For sine? Yeah, it's the same. Sine of 7 power 4 is the same as sine negative power 4. Sine of 7 power 4 is negative square root of 2 over 2. I use the negative square root of 2, no? I'm using this r. I'm using this r. Negative square root of 2, comma, if I, these are the same.
I was just confused how we got a negative 1 and a 1.
Oh, because this is a negative, but this one, the cosine of 7 power 4 is a positive. And negative times the positive is a negative. You know what I mean? Like the evaluation of cosine of 7 power 4 is a positive square root of 2 over 2. Here, I'll show you. I'll show you with a calculator, because it is a perfect number anyways. Check it out, Salali. Check it out. Negative square root of 2. And then I'm going to multiply this by cosine. You said 7 pi over 4? 7 pi over 4. Enter. Look, negative 1. Negative square root of 2. Sine of 7 pi over 4. Or whichever radian you like best. And check it out. 1. But don't just trust the calculator. Make sure we understand the concept why. Right? Did I answer your question or no? No. Tell me. I want to know.
I just I don't know. Look at it a little bit.
Okay, I'm gonna come back and we're gonna talk. Okay? No pressure. I don't mean that in a. Did I sound mean? I didn't mean it like that. I mean like we're gonna chat math life. Okay, here we go. Go to the next question, guys. All right. So now these are in rectangular and they want polar. And they want 2 different sets. So it says 2 different sets of polar. We're going to go slow. You guys ready? So 1, 0 is like right there. So in polar, I can do a revolution. And what is the distance from the origin to 1, 0? Is it 1 again? So in polar, I can say 2 pi as 1 revolution and 1. Or I can do 2 revolutions. I can say 1 comma 4 pi. I mean, usually you want it between 0 and 2 pi. Or you can say 1 comma 0. Okay, hook me up. What if I want a negative 1? Then what radian do I want to use if I want a negative 1? Perfect. You guys got it. If you can go to pi and then go negative 1, you're at 1, 0. Good job, guys. You guys are beasts. You're ready for everything. You're ready to do taxes. Okay. All right, here we go. Yes.
Can it be anything else besides just pi?
Well, it can be negative 1 comma 3 pi. It can be 5 pi, odd pi, any odd number pi. You know what I mean? As long as you're there. All right, here we go. The next one, negative 3, 3. Ooh, that's going to be a tough one. Let's see. 1, 2, 3, negative 3, 3 is probably going to be like, bam. Okay, there it is. Here's my negative 3, 3. It's not quite perfect. 1, 2, 3, 4. 3 squared, 9, 18 squared, 18, 9, 3 squared. Oh, yeah. It's going to be somewhere between 3. Okay, yeah. It's right there. We're good. All right. Ready, guys? I hope that you can see. All right, guys, focus. Look, I know that you guys have logic and you guys have common sense, and I think you guys can tell, well, the x and y value have the same magnitude in the unit circle. Anytime the x and y have the same magnitude, it's always going to be something over 4, something pi over 4. I'm in quadrant 2, so it's obviously going to be 3 pi over 4. But if you didn't know that, now remember, guys, the calculator is stupid. I would not do this. I would not go arctan of negative 3 over 3 because the calculator is going to give you negative pi over 4. It will. But notice, negative pi over 4, is that the answer I want? Look, watch. If I go arctan, remember, the calculator is dumb. Negative 3 divided by 3, because that's what we said, y divided by x, right? And look, it gives you that answer. Chop, how do you know that? That's not negative pi over 4. Yeah, it is. Look, pi over 4, but negative. Look, it's the same digit. But see how it gives you negative power? See how it gives it to you in quadrant 4 instead of quadrant 2? Come on, Sanchez, focus, miss. All right. Do you guys know what I'm trying to say or no? No? Okay. Look. Guys, look at where that point is at. No, they gave it to me. They told me, negative 3, 3. Oh, okay. All right, guys, hold on. Let me answer one question at a time. Okay. How do I know that that point was right there perfectly on this grid? As soon as I see the x and y that have the same magnitude, I already know that it's going to cut that quadrant in half. If I were to draw a ray through the origin in that point. Because it's the same, like in the unit circle, think about it. Square root of 2 over 2, comma square root of 2 over 2. The x and y have the same magnitudes at all the 45 degrees, the pi over 4, the 3 pi over 4, the 5 pi over 4, and the 7 pi over 4. Yes or no? Okay. But if you didn't know that, it's okay. You could have done this. You said, well, I have a formula here. So look at this formula that we wrote right here. Notice that we put, to find that angle, it says arctan, and we put y divided by x. Do you guys notice that? And if we do that, so here's where I was trying to tell you guys, maybe to always use the reference angle. If I put, the calculator is stupid. Well, it's not stupid. It's just programmed. It's just running a program that you do. It does arctan of this, and it recognizes that's -1, and it gives you negative power 4, which is the correct, because at 7 power 4, it is also -1. So this ray is -1, and this ray is -1. But the calculator doesn't know. The calculator doesn't know which quadrant you want, but you do. Does that make sense? So here's what I would recommend. And I think Delta agrees with me in this, because I think Delta does the same thing. I would recommend you always find your reference angle. Chop, how do you find your reference angle? I'm going to go theta r, that's your reference, and I would go arctan, and I would just take away the negatives. 3 over 3, so that's just arctan of 1. And you know, know the unit circle, where is tangent 1? At pi over 4. Now remember, this is a reference angle. What quadrant is -3, 3 in? It's in quadrant what? 2. So then you say, well, that means, here's my R. That means this is your reference, so that must be pi over 4. I know that from here to here, that's pi. So then you in your little mind say, if I want theta, I'm not calling you little. I'm just saying, like, your mind that's little. I would never be little, you guys. You go pi minus pi over 4. Well, I have a whole pi here, pi over 4. And I'm subtracting 1/4 of a pi. Oh, that must be 3 pi over 4. So that's the angle in quadrant 2. Yay or nay? Oh, man. Don't worry. We need more practice. We need more practice. We will do more practice. If you want to put the negative, fine. Remember where you were at. Like, oh, negative pi, it can't be negative pi over 4. Add pi to the negative pi over 4 and you'll be there. Tan, arctan, just do plus pi n. So I guess, let me write that in the formula here. If you want to use your y and x, let me write this in the formula. And then just put the note. Where are you? Okay, let me fix this formula then. So go to the formula, because I know some of you guys. And then just write this. Plus pi n. And then just put check what quadrant theta is in. There it is. Now you don't have to think. Now you don't have to think. Y over x, whatever the calculus spits out, add pi. Cool or not cool? If you're in quadrant 3, the calculator is going to give you an answer in quadrant 1, add pi. Done. If you're in quadrant 2, the calculator is going to give you an answer in quadrant 4, add pi. Done. And if you're in quadrant 1, you don't have to do anything. It just spits out your answer. If you have a CAS, it'll spit it out in terms of pi. If you don't have a CAS, it'll give you a decimal. Use Wolfram Alpha. Wolfram Alpha will give it to you in terms of pi. Okay. Yes?
So we only do like the plus 2 pi when it's...
The plus 2 pi, you only do it with sine and cosine, because sine and cosine repeats every 2 pi. Tan repeats every pi. So, you know what I mean? You only use the plus pi if you're in quadrant 2 or in quadrant 4. Because when you're in quadrant 3, if you're in quadrant 4, it's going to give you a negative angle. Just add 2 pi to that. Yeah, because it gives you a negative angle if you want an angle between 0 and 4 pi. If it doesn't restrict you, your angle, if it just doesn't tell you anything, delta tells you give me an angle between 0 and 2 pi. If it doesn't restrict your angle, you can just leave it alone. Give me the negative angle. It doesn't matter. Okay. Are we okay? Don't worry, guys. As soon as you practice, I think you'll be better. Look, 0. Oh, did I answer the question? I didn't, right? We didn't give the polar. All right, polar. Here we go. Here's my 2 coordinates. Oh, I need my r. Here it is. You can write right here, guys. R squared equals -3 squared plus 3 squared. Job. How did you do that? Right here, guys. Right here. It tells you x squared plus y squared equals r squared. Cool or not cool? Yeah, this formula for r. See? X squared plus y squared equals r squared. That's going to give you my r. That's what we're looking for, guys. We're looking for polar. All right. Be careful. The calculator is a dumb machine. Remember, if you put -3 and you just square -3, it's going to give you -9. Negative times a negative is a positive, guys. So use parentheses. So here we go. R squared equals -3 squared is 9. 3 squared is 9. 18. How do I get r by itself? Square root. R equals the square root of 18. Delta actually takes that. I would prefer that you know how to break it down. 9 times 2 is 18. What's the square root of 9? So 3 square root of 2. So here is my coordinate. I'm going to write it right here. My one coordinate is 3 square root of 2, comma, what's my radian? 3 power 4. That's one of them. It wants 2 of them. It wants 2 answers. It says, give me 2 answers. Give me 2 different sets of polar. You could say, what can you say? You can say 7 power over 4, and then put a negative in front of this. Negative 3 square root of 2. If we count backwards, does that make sense? Yeah, there it is. These are my 2 answers. How do we feel? Okay. Let's do, this one's pretty simple. Number 3 is going to be pretty simple, guys. I know. This is not the most exciting thing in the world. 0, negative 4. 0, negative 4 is right here. Cool or not cool? First, do the angle. What is this angle right there that I just did? How much should I rotate? I'll go slow. 270, but give it to me in radians. 3 power over 2. So, in polar form, my radian is 3 power over 2. What is the distance between the origin and negative 4? Now, be careful. Just the distance. 4. Okay. Someone give it to me if I want negative 4. What's my angle if I want negative 4? Pi over 2. Good job. Notice we didn't do any math. We just did it with logic. Chop, I want to use the formulas. Okay. If you want to use the formulas, here it is. R squared is equal to x squared plus y squared. Look at that. R squared equals 16. Square root. R equals 4. Okay. How do we feel? All right, last one. And then we'll get you guys started because the next is on Monday's notes. Here we go. I exaggerate the quadrant to negative 1, 1. And I put a point, negative 1, 1. So here it is. You guys already know this point because we did it earlier by design. And then here's my R. This is my R. And this is the angle I want. So here we go. Maybe if I go slow on this one, we will understand. Do you guys see this triangle? Okay, the first thing I'm going to do is I'm going to find R. R squared is equal to negative 1 squared plus 1 squared. Does everyone know how I'm doing that? Pythagorean theorem, right? Okay. R squared equals negative 1 squared is 1, and 1 squared is 1, and what's 1 plus 1? 2. And I don't want R squared equals 2, I want R. So what do I do next? Square root. R equals the square root of 2. Perfect. All right, here we go. I'm going to go slow, really slow. You guys ready? All right, I'm going to go arctan, and I'm just going to use my notes. Y over x. Y is 1, x is negative 1. Arctan of negative 1. So tell me on the unit circle, where is tangent negative 1? There's 2 of them. One in quadrant 2 and one in quadrant 4. Give me the radian in quadrant 2. 3 pi over 4. What's the one in quadrant 4? Which one are you going to use? Why? Because you're in quadrant 2. See? So that is 3 pi over 4. Are you shocked? You are not shocked. The x and y have the same magnitude, so you are expecting it to be one of the power 4s. Power 4, 3 power 4, 5 power 4, 7 power 4. One of those. If the x and y coordinates have the same magnitudes. So here we go. Here's my coordinates in polar form. Square root of 2, comma, 3 pi over 4. That's one of them. Give me another one. Negative square root of 2, comma, 7 pi over 4. Are we getting it? We're not pros, but we're getting it, right? Okay, we're not ready for the rest. Save this. If you want, you can do this. The you try, that we're ready for because it's just you trying it again. But we're trying it again right now. You know what? No, you know what? Let's do some. Let's do some together before we release you guys. Just because I want to make sure that you know it. So let's look at letter B. Oh, yes. Yes, letter B. Letter B is perfect. Number 2, letter B. Notice I didn't put a grid. I did that on purpose. Okay, don't worry, guys. We're going to go slow. We're going to go so slow. You guys ready? This is in quadrant. What quadrant is that in? Positive X, negative Y. Quadrant 4. Exaggerate quadrant 4. All right, guys. Focus, focus, focus. Focus, focus, guys. Focus. We're in quadrant 4, so exaggerate quadrant 4. You don't have to be perfect. I'm not asking for perfection. 1 comma negative square root of 3. I'm going to say that's like right there. 1 comma negative square root of 3. And then I'm going to draw the R. This is R. And let me see. Here's my right triangle. And I'm going to say this is the angle I want. That's theta. We're going to go slow, guys. Don't worry. I want this in polar form, and I want 2 of them. You guys ready? Here we go. I'm going to get the R. So I'm going to write R squared equals 1 squared plus negative square root of 3 squared. You don't need a calculator, but if you do, that's fine. 1 times 1 is 1. And negative square root of 3 times negative square root of 3 is 3. Does everyone see how we got that? Okay. Then R squared equals 4. How do I get R by itself? Square root. R equals, don't write plus minus. Just give me the positive 2. R equals 2. Are we okay? All right, next, I want to get my angle. So here's where I'm going to go slow. So I'll wait for you guys to catch up because I can see some of you guys still writing. I want to get my angle. So here we go. I'm going to go arctan of negative square root of 3 over 1, y over x. And then I say, well, that's just arctan. And I know I'm bleeding into the next one, but that's fine because we probably won't do letter D anyways. Let me scratch it out. Arctan of negative square root of 3. These are all going to be perfect coordinates. So you ask yourself, tan of what angle is negative square root of 3? So then that's what that means. Tan of what angle is negative square root of 3? Yeah, the unit circle doesn't go away. So you think about the unit circle. And I'll slow down. And I know, remember that tan is y divided by x. I know that the only way it's going to be negative if you're in quadrant 2 or quadrant 4. I need to either be, let's see, y value. I need to either be here or here. Yeah, I think I hear some of you talking correctly. I need the y value to be the square root of 3 over 2. Because it's y divided by x. So I need square root of 3 over 2 in the numerator and a negative half in the denominator. Or I need a negative square root of 3 over 2 in the numerator and a positive half in the denominator. Remember that tangent is y divided by x. Cool or not cool? What is this radian right here? In quadrant 2? 2 pi over 3. And in quadrant 4 it would have been... Yeah, 3, 6, 5. 5 pi over 3. All right, what quadrant is my coordinate in? The one on letter B. It's in quadrant 4. So which one am I going to use? The 5 pi over 3. Do you see how we got it, guys? So let's give 2 answers. One answer is 2 comma 5 pi over 3. Give me another answer. Negative 2. If I put negative 2, what's my radian? 2 pi over 3. Good job. You guys are getting it. Cool or not cool? This is all you're doing today. Because we need to talk about circles and ellipses before we can graph polar. This is all we're doing today. I think the next class we might do circles and ellipses because I don't think you guys have experience with that. And then we can start graphing polar. So all you're doing today on delta is plotting. You're just converting. You're plotting and converting. That's all you're doing. Is that easy? All right, guys. Log into delta. Take care of that one assignment. That's all we're doing today. Good job.